Aloha and welcome. In this video, we're going to be talking about embedded systems. Embedded systems are specialized computer systems that are built into a larger system and they control certain aspects of that larger system. So there's a lot of terminology that we need to go over here. One is custom firmware, or what we call aftermarket firmware. And this is unofficial, new or modified versions of the firmware created by third parties for devices to provide new features or unlock hidden functionality. For example, you can get third-party firmware or aftermarket firmware for routers if you want to install like open source routers. I have had network attached storage units that essentially hard disks that you can put online. I've had those when my old D-Link DNS 323 network attached storage was no longer when it was discontinued and had gone past 10, 15 years, there were options that I could put in for operating systems on that I can re-function it. So you've got these aftermarket firmware that can be used to control, or they can be used to update these old pieces of hardware. And some of the methods that we use for that, we can do over the air firmware, which is called OTA firmware. And that's the wireless delivery of new software firmware to mobile or embedded devices. Another thing to keep in mind is that many embedded systems out there, their applications operations have time constraints. They really have to respond in a very tight time boundary. So these things have real-time operating systems known as RTOS, and I guarantee you're probably going to see that on a test. So remember that real-time operating systems are operating systems that prioritize the data processing so a system can respond to changes within a limited time frame. Example is baseband processor, a BP that we talked about in the previous lesson. It's a network interface controller chip that manages all of an antenna's radio functions. And the baseband processors run an RTOS as its firmware. An example is your iPhone. There's a number of embedded devices out there. I've got one right here, if it shows up. This is a Raspberry Pi. Raspberry Pis are small single board computers. They've got everything on here. This is really an amazing little computer. It does quite a lot with very little, but it's pretty interesting in what it can do. But this little computer, it's less powerful than a large computer, but it's got a lot of functionality that it can do. It runs Linux, or a version of Linux. The Raspberry Pi that I've got here is running its own specialized operating system. But we've got security considerations that we have to take into account for these. And another thing is, what can you do with this? You can use these for all kinds of applications. You can attach, there's little input-output pins over here, and you can attach devices to it to do sensory input. And so you can set up like temperature, humidity checks and things like that. So there's security considerations that we have here, though. We've got networking vulnerability. The OS can be modified if somebody has physical access to it, because there's just a small disk that goes in here, or actually it's in this end. There's a small disk over here. So if somebody has physical access, they can modify that. And but there are things you can do to harden it. We talked about hardening systems before. You can harden a system like this to shut down the things that aren't being used. We have a smaller version, which is about this big. The Raspberry has one called a small chip called the Pico, and the Pico is a neat little microcontroller. And Arduino, there's Arduino microcontrollers as well. Microcontrollers, they're very limited in their capability. They usually run a single program at a time, and they are essentially do one task. So you've got standard I/O, including USB on it. You can add networking. Sometimes you can add wireless networking on it too. The concerns there, the USB interface can be exploited. The attack surface is increased if networking capabilities are added. And the limited capabilities mean that there's going to be limited damage in case of an attack. There's something else called field programmable gate arrays, FPGAs. And FPGAs, they're reconfigurable computing devices. It looks like just a chip. It looks like a CPU if you look at it. And those are pre-programmable integrated circuits that are customized to perform a specialized function. And it can be reprogrammed. And the whole idea of field programmable, it can be done on the fly. So an attacker could reprogram it, but the threat is limited by the capabilities of the FPGA. If it's very specialized for something, then, again, just like the microcontroller, you're going to have a limited number of things that you can do with it if you exploit it. Internet of Things is another big area of concern. There's a lot to Internet of Things. It's a catchphrase for things, but think about Internet of Things is essentially all the devices that you have that are giving inputs that are, these smart devices that we call. We've got security cameras. We've got, your refrigerator now may have, smart features on it. You've got Ring doorbells, Google Nest, all these things, these sensors and devices that make up your smart home. These are considered Internet of Things devices, IoT devices, we call them. They help facility automation, and they do things like they help automate routine tasks at facilities. They use sensors. So some of the common IoT devices are going to include sensors that measure physical properties like temperature and humidity. Could be a smart device, which is an internet-connected device capable of data processing. It's user customizable through the installation of apps and other software. And you've also got wearables like your watches and things like that. And those are collecting information. And these devices, they all have security concerns as well. So when you're talking about sensors like the temperature and humidity sensors, these things are vulnerable to attacks. Like if you've got an HVAC sensors for air conditioning, things like that, they communicate with insecure building protocols. So that's a concern. With smart devices like your phones, you probably have heard of all kinds of attacks on those already. Let's just take the iPhone. So if your iPhone is lost, so if you lose your iPhone, that could be hacked. You've got Bluetooth exposure attacks that we talked about, but again, Bluetooth 5.0 and up, and you're safe. Also, exposure is reduced by traffic separation. When we're talking about wearables, there's a lot of issues with these. So network data exposure must be reviewed and mitigated. You've got data exposure to third parties because all the data that's being collected on these devices, they're going somewhere. So who owns the data? So for my watch, it goes to Apple. Does Apple share it with anybody? Can I share it with anybody? Can it be inadvertently shared with others? You have to worry about these things. A funny story, the military banned use of GPS-enabled devices by their service members because they found that some of their service members, when they were stationed overseas, they were going on jogs, and I think it was Strava, or I forget who exactly it was, but I think it was Strava. They were using their wearables when they're going out for their runs and things like that, and recording their routes for personal edification, and that was very weak because other people could see where exactly they're going. And if people are able to monitor troop movement, that's not a good thing. So the U.S. military banned the use of it once they found out about that. So IoT security considerations. There's a lot of things to be to keep in mind. Normally in a computing environment, you've got your centralized security professionals at the organization that are looking over the security details and everything. But if you've got people that are bringing their own devices in there, if they've got their wearables or they've got their smart devices, that's outside of the organization's control. So that's something they have to consider. So you've got a lot of issues there. One is the data handling and storage. So an IoT device, it may send data to the cloud for storage and processing. So proper vendor data handling and storage is critical. You've got networking because the data in transit, the data when you're sending it or receiving it, it's vulnerable. So one of the problems if you're using IoT devices is, your hardware, the hardware you use may be limited in what it can do. So it may not be able to do encryption. So that's a concern. You've got limited hardware and software capabilities. So since they're simpler, the security capabilities, like I said, are limited. you've got weak defaults on a lot of these things. So some of these devices are notorious for having default usernames and passwords. Same thing on Raspberry Pi or any other Ring doorbell or things like these. A lot of them have they've got pre-programmed usernames and passwords. And if you don't change those when you deploy something, you'll find yourself in a bit of a pinch there, because attackers will find that and they will exploit it. Another thing is a lack of support and software upgrades. So vendors may not provide consistent software patches. So you want to make sure that the vendor that you're dealing with, they do update their packages often. You want to make sure that they've got well-supported devices. Other things with proprietary hardware and software. Sometimes you've got hardware and software that's it's proprietary. It's owned by a single company, and that company, they could go out of business. They may not. They may sunset a product and no longer provide updates for it. So those are going to be vulnerable. So yeah, these are things that you have to be concerned about. There's other IoT security threats and vulnerabilities. There's man-in-the-middle attacks, and that's where an attacker eavesdrops or modifies the communications between two parties. You've got eavesdropping attacks. And that's an attack when the data in transit is intercepted by an attacker. You've got firmware hijacking. That's an attack when an attacker takes advantage of outdated firmware to take over a device. You've got botnets too. Worst thing in the world is if somebody was to come into your environment and take over all the end devices that you have, or all these IoT devices, and use them for crypto mining or whatever they want to. That's a big problem. So you want to make sure that your IoT devices don't become just part of somebody else's zombie botnet. And then we've got a couple of things we've alluded to before, but we've talked about SCADA and ICS. So SCADA is the Supervisory Control and Data Acquisition. It's a type of industrial control system, ICS. And these are used to monitor industrial systems. When I'm talking about industrial systems, I mean chemical plants, water processing plants, sewage processing plants, all these types of places that are, they're large industrial things. They use two different types of components. One's a Remote Telemetry Unit, RTUs. They're also called remote terminal units or remote telecontrol units. But the general idea is these are sensors that are monitoring things. For example, your water, if you've got a water meter that recently Hawaii Electric has come out and put monitoring on everybody's systems, so they don't have to go out in the field and get this information. That's an RTU. There's also programmable logic controllers, and the programmable logic controllers, the PLCs. The PLCs actually monitor something, but they also take actions based on inputs. So they can change like the water flow, or they can change different processes. So that's something to keep in mind as well. So that's the section that's everything we're going to cover here. We've got embedded systems. Remember, embedded systems are systems that are parts of larger systems. They can have custom firmware. You can deliver updates through over-the-air firmware updates. A lot of these are real-time operating systems. They need real-time operating systems because they're very time critical in their process. And we talked about the Internet of Things and the security issues that we have to deal with. We've talked about what they're used for. We've talked about sensors, smart devices, and wearables. We talked about the security concerns involved there. We talked about a lot of the threats and vulnerabilities like man-in-the-middle, eavesdropping, firmware, hijacking, and botnets. So, lastly, we talked about SCADA and ICS and knowing the difference between the RTUs and the PLCs. So that's it for this section. If you have any questions, feel free to reach out and I'll be happy to explain it in more detail. Aloha.